Hello, everyone. I want to thank you all for joining us today for our Webinar Wednesday series. My name is Kelly Hall, and I'm a marketing coordinator here for ALS North America. Our presenter today is Nicole Bryson. After completing her undergraduate degree in chemistry at St. Lawrence University, she worked as an analytical chemist in the pharmaceutical industry. In 2000, Nicole proceeded to complete her MBA in marketing from Pace University in White Plains, New York. She has been working in the environmental industry for the last 15 years and has specialized in air and vapor sampling and analytical methodologies for more than 10 years. Now she is the technical sales manager for the ALS laboratory in Simi Valley, California. Today, Nicole will be discussing 325B Fenceline monitoring for benzene. During this presentation, feel free to use your chat box, ask a question, or raise your hand features to ask questions. Most of our questions will be answered at the end of this presentation. Nicole, thank you again for taking your time to deliver this presentation today. I will go ahead and turn it over to you.
Okay, great. Thank you very much. Just as a technical question, Kelly, there is a box on my screen that says start broadcast or not now.
I have already started the broadcast, so you can just ignore that.
It's just I can see it in the middle of my screen. Okay.
Okay.
So thank you everyone for joining us today. As an analytical laboratory, we're in a unique position to have a year's worth of analytical data. I have to get that box out of there. You know, 325B monitoring started, a number of years ago, and starting in 2018, everybody had to begin monitoring for it and reporting to the EPA. So in advance of this data being available publicly on the EPA CEDRI database, we are sort of in an interesting position at this time to be able to look at all of the samples we've tested over the last year and kind of look to see, well, how's it all going? Since this regulation was begun and people had to start monitoring, what does that data look like? And since we're an environmental analytical laboratory and we had a big data set, we thought we'd take a look at it and share some of that information. So from January 1st of 2018, we received samples from 32 refineries throughout the United States for a total of over 15,000 samples. We also had field blanks and duplicates, so we had a total of 16,581 samples to look at for our data set. So we took a look at that to see, what kind of trends we might be able to pull from that information, and that's what we'll be discussing today. Just a little context to remind everybody of how we kind of ended up here and why we're doing this and what this is specifically. In December of 2015, the EPA finalized a rule updating the NESHAPs for petroleum refineries, which required all major source refineries to monitor and report benzene concentrations around the fence line of their property. This was significant in that prior to that, you hadn't had to do that, and it had only been capturing emissions within the facility. So EPA method 325B was developed with EPA 325A, and this method, 325B, utilizes passive sampling to do the benzene monitoring. It utilizes these stainless steel tubes, and for anyone that's done this in the last year, this will be very familiar to you. You have these stainless steel tubes that are filled with a carbon-based sorbent. On one end, there's a diffusion cap, and these tubes are deployed for 14 days, and every 14 days, the samples are collected and replaced with another set for 26 sampling events per year. Here's an example of what it can look like in the field. This is one of the shelters from our customer. They can be open like the one on the left, or they can have a screen on them like the one at the right. The one, if they have screens on them, can help keep out bugs or critters or, in situations where they might be, potential for that, such as this picture, which I find fascinating and terrifying all at once. It's an example of a customer's shelter that got taken over by hornets in the 2-week span since they were there. So don't do that. 325B requires that you measure the concentration of benzene, and then you calculate a delta C. the delta C is the difference between the high and low for a given sampling event, and the operator has to determine the rolling annual average delta C. So it's the average of your 26 most recent periods. The action level for benzene is 9 micrograms per cubic meter on an annual average basis. If your concentrations are below that number, below 9, then no action needs to be taken. If you get results above 9 micrograms per cubic meter, then you need to do a root cause analysis and potentially take corrective actions. So 9 is the number that has been established that you want to be less than. Further, if an individual point can consistently achieve results at or below 0.9 micrograms per cubic meter, then you can start reducing the frequency of the monitoring and sampling. So those are the two key numbers that we need to achieve, are 9 micrograms per cubic meter and 0.9, as anyone involved in this program is familiar with. So as we were looking at our data, I was thinking, what are the ambient average concentrations of benzene? Like, how hard is it to achieve 0.9? Because as an air and vapor testing laboratory, we know that background concentrations of contaminants in ambient air can be found even at the North Pole. So what's the average benzene concentration in ambient air? Now, of course, this can vary significantly. An average obviously is just a ballpark number, and it can vary significantly based on, urban air, rural air. But we did look up, excuse me, the most recent data we could find from the 2013 National Monitoring Program's annual report for a benzene concentration. And from over 1,800 measurements, the average ambient air concentration for benzene was determined at 0.78 micrograms per cubic meter. So that means that if you're trying to get your numbers less than 0.9 and the average ambient air concentrations around 0.8, that's a pretty high bar, or actually a pretty low bar. We also found this resource from the EPA, which charted ambient benzene concentrations in the US for the last 15 years. And the blue portion of the chart shows the 10 to 90% range, with the median and the average. So again, you're looking at median benzene concentrations that are less than 1 microgram per cubic meter. So what the regulation is requiring refineries to achieve is pretty challenging in the context of ambient air concentrations. So that said, let's take a look at our data set. So we had over 15,000 samples. Of those samples, the average result in micrograms per cubic meter was 2.6 micrograms per cubic meter. The median, the number, 50% were greater and 50% were less, is 1.0 micrograms per cubic meter. So in the context of what this regulation is trying to achieve and the numbers we're trying to get, these are pretty low numbers. The maximum reported was 1,000, and the reporting limit is 0.38. The reporting limit is significant to a laboratory in that the reporting limit is how low are we looking? How low can we report? And the reporting limit typically represents the low point of your calibration standard. So we're looking down to 0.38 micrograms per cubic meter. If it's less than that, then that's a non-detect. And out of our data set, there were over 800 non-detects, or about 5% of the overall samples were non-detect. So for the samples with detections of benzene, we look to see where those concentrations lie. So if our magic number is 0.9 micrograms per cubic meter, 43% of the samples were less than that number. So that's good news for a lot of refineries, since that means if they can consistently achieve that number, they can begin to reduce their monitoring. The other number we want to keep our eye on is 9 micrograms per cubic meter, and 98% of the samples are less than 9 micrograms per cubic meter. So in terms of what this regulation is trying to achieve, I would say that that's good news for the industry. How many were greater than 9? Only about 2% of the samples, about 300. And there were only a couple that were greater than 99 micrograms per cubic meter. This is a graphical representation of the sample distribution and the concentrations. The concentration is on the horizontal axis, on the x-axis for micrograms per cubic meter, and the sample count is on the left-hand side, how many of them were in that range. And again, 43% of the samples are less than 0.9, and 98% fall within this entire chart area. We look to see what caused these outliers. So if we look back to see, because our clients were indicating that these outliers can have a disproportionate effect on their own data sets. We look to see where were these big ones coming from, the greater than 99 micrograms per cubic meter. And all but 2 of those hits came from one location. So one location was having these high detections of benzene. And for the hits greater than 9, 82% came from 2 locations. So the number 1 location and the number 2 location really represented most of those exceedances. When we spoke with our client who had the big hits, we were just curious, like, what's going on at your site? Like, what's your circumstances? And when I spoke to this client, he said, yeah, we've got some interesting data, don't we? I said, yeah, that's one way to call it. Well, they indicated that they had a feed storage tank that was located within 50 feet of the fence line. And that was really throwing off the sampling station for those particular results. Since the beginning of the monitoring last year, they took the tank out of service, and their results have significantly improved. We charted the average benzene concentration at all the sites that we worked with last year in no particular order, just kind of showing, the range of concentrations that we saw. And the red horizontal line represents the 9 micrograms per cubic meter goal, or rather action level. If we sort them without that big outlier with the high average, then you can see how the refineries are performing a little bit more closely with the scale on the left-hand side of the benzene concentration of micrograms per cubic meter. And then, we can see that of our data set of 31 refineries, 9 of them are actually less than that goal of 0.9 micrograms per cubic meter, and all of them are less than the action level of 9. We wondered if there were any geographic or regional tendencies. For example, we were wondering, California has notoriously strong environmental regulations, and we wondered if that had anything to do with it, like, was the West Coast specifically better than some other regions? So we grouped them a little bit sort of by, kind of broad categories. The California refineries are all less than 2 micrograms per cubic meter for their benzene concentrations. The Midwest refineries we worked with, there really were no trends that we could see geographically. So once we looked at the sample sets, just to see what the trends were, we looked at the QC samples, which are also part of 325B. 325B requires you to collect field blanks and duplicates as part of your sampling process. The first one we'll look at are field blanks. So field blanks are an assessment of both the environmental conditions and of laboratory precision and QC. So a field blank gets treated the same way as a sample tube. It's QC'd the same way, it's the same tube, it's from the same set. Everything about it is the same as the samples in that grouping. The difference is that the field blank just goes along for the ride. says my audio? Okay, looks like my audio cut out. Sorry about that. This slide just looks briefly at a distinction that laboratories make between reporting limits and detection limits before we talk about the field blanks. We say this because this term can be used pretty interchangeably outside of laboratories, but it means very specific things to laboratories. A reporting limit for most laboratories means it's the lowest number for which data can be quantitatively reported. And that's because the reporting limit is associated with a calibration standard. So if a laboratory tells you that their reporting limit is 0.5 micrograms per cubic meter, that's because they have a calibration standard at that point. So they know that that number is true. The detection limit is a number that's less than the reporting limit, and it does not have a calibration standard associated with it. That number is statistically derived. The laboratory knows that it's not zero, and it's not just noise, but the closer you get to the detection limit, the greater the uncertainty is with that number. So if the laboratory tells you our reporting limit is 0.5 and our detection limit is 0.05, that means that at 0.05, we know that it's not zero, but there's uncertainty with that number. I see that because that is how some of our field blanks are reported. We saw almost 600 field blanks. The average reporting limit is 0.38. So how many times did we see benzene above the reporting limit in those 600 samples? Only 5 times. So less than 1% of the field blanks that we saw all of last year had reportable benzene concentrations. Now, sometimes our clients would like us to go even see how low we can go and then report to the detection limit, which for most of these samples was 0.15. In those instances, we did see some benzene above the detection limit. In this case, almost 70 samples, 69. And so there were 69, but those were still less than the reporting limit. The biggest hit that we saw in a field blank was at 6 micrograms per cubic meter. So overall, what this says is that if only 5 samples out of 600 had reportable benzene, then that indicates that the process from going from the laboratory to the field and back and the laboratory QC processes are good because there's strong data integrity. If less than 1% of the field blanks are getting hits, then that's a good indication of that process overall. We looked to see why we had hits in the field blanks for the 5 that were above the reporting limit. For 2 of those samples, the results were almost a perfect match for the same station where they were deployed with the sample. Excuse me. So you can see here sample 1 was 6.6 and the field blank was 6.3. And then the sample and the field blank for the other one were the same number. What we think happened is that the field blanks were accidentally sampled, that the caps were taken off. Both of these field blanks occurred early on in the monitoring in 2018. So we can't confirm this with that particular client, but we think that it was just a mistake early on and that the field blanks were sampled just like the samples. Some of the other detections for the other 3, it could be due to some inherent benzene artifacts that are in the sorbent. The sorbent that's used for this sampling is a carbon-based material, and there can be benzene in it just inherently. We learned that desorbing it at too high a temperature can release more benzene. So we have optimized our analytical and QC procedures to do that. We also do other things to minimize potential reporting of potential benzene in the field blanks, like segregating the sample kits, having dedicated field blank tubes, good sample integrity in the transportation process, and identification at the laboratory. Another part of the QC are duplicates. So the duplicate is an assessment of the precision and accuracy of the method and the laboratory. We saw almost 600 duplicates last year. The average, difference between the duplicate and the sample was about 10%, 8 to 10%. Keeping in mind that the average concentration was about 2.6 micrograms per cubic meter. So that 10% would have been maybe 0.2 to 0.3. The biggest difference between a sample and duplicate that we saw was 14, and the biggest percent difference was between a sample that was 0.6 and a duplicate that was 9.3. For those, we tried to investigate to see what might have contributed to those differences, and it can be challenging to find that after the fact, so we don't have any data regarding why those duplicates might have had that variation. In looking at the data set, we wondered what else we might be able to, any other trends we might look at from the data set. Is there a relationship between temperature and benzene concentrations, for example? So we plotted the benzene concentration on the vertical axis and temperature on the horizontal. And when you have 15,000 data points and most of them are less than 5 micrograms per cubic meter, but you have some as high as 1,200, plotting them like this is not very meaningful, considering 98% of the data is less than 9. So that was not a useful chart. We tried it logarithmically by plotting it logarithmically on the y-axis and again the temperature on the x-axis. No real trends observed there. We took out hits greater than 100, since we knew that made up a very small proportion of the data set. You can see a little trend line down there by the horizontal axis that there can be some relationship between the temperature and the concentration. But again, when 98% of the data is less than 10, it can be difficult to see any trends with this plot. So then we took out everything big greater than 9. So ultimately, there can be potentially some relationship, but it doesn't look very strong. Then we plotted the benzene concentration versus date for all of the sites. And when you plot concentration versus the date upon which it was collected, well, then it definitely looks like there is a relationship, a causal relationship. But again, keeping in mind that those big hits are from one location, this one particular refinery, and this was what their plot looked like. So at that one location, it does look like there could have been that relationship. So when you take that refinery out of the broader data set, then for all of the other ones, it really doesn't look like there's much correlation between the benzene concentration and the date, or the concentration and the temperature, which presumably increases with that time. Maybe it did at that one particular refinery, but it doesn't look like overall it has much of a relationship. So those are some things that we looked at with our data set. We would be happy to, if you have any other ideas about what you might want to know from 15,000 data points, I would be happy to take a look at that, or see if we can see any other trends in case you want to peek at, the big everybody else's data and see what they're going through. I mean, part of why we shared some of this is that if your refinery or your operation hasn't had some of these exceedances, then you can see that your location's doing well. And if you did have some of these exceedances, then you can see that you're not the only one. So that concludes my portion of the presentation. If anybody has any questions, I'll be glad to answer them.
Thank you, Nicole. Yes, we will go ahead and open it up for questions. Again, feel free to use your chat box, ask a question box, or even the raise your hand feature to ask Nicole a question directly. We'll give everyone a few moments for them to write those questions down. We did have someone mention that when your microphone did cut off, you were talking about field blanks. They wanted to know if you could repeat some of a few sentences after the field blanks.
Yes, I'm sorry about that. I don't know what happened. Field blanks. So 325B does say that you need to do certain QC elements, field blanks and duplicates. Field blanks are an assessment of the environmental conditions and of the laboratory process. So a field blank is treated the same way as a sample. It's from the same sample set. It was QC'd the same as the samples. It's the same sorbent. It's the same set. So everything about the field blank is the same as your samples. Your field blank goes out with the kit. It goes out with the sample. It gets deployed, but the diffusion cap does not get taken off. So that's the only difference, is that it doesn't actually collect a sample. So it's supposed to be an example of what are the field conditions that it's exposed to and the laboratory process. So that's what the field blank does. And out of the 500 samples or more that we saw that were field blanks, we only had benzene reported above the reporting limit in 5 of them. So less than 1% in a year had benzene detections. So that is a good indication that overall the process that the lab conducts to keep them clean and free of contaminants, which is also an indicator of the rest of the QC, shows that there's good integrity and robustness in that process.
Thank you, Nicole. We do have a hand raised from Kathy. Kathy, you can go ahead and unmute yourself and ask your question to Nicole.
Oh, hi. This is Kathy Doherty with DSE. How are you? Thank you.
Hello.
I worked for 10, 15 years in chemical plants, not necessarily refineries, but we had onboard GC monitors, even back then when dinosaurs roamed the earth. But
Sure.
we saw a very big significance, not just to temperature, but to humidity and barometric pressure with benzene and the other volatiles. I guess I would say, have you seen that? I know you said there's not a correlation to temperature alone, and we saw a very big correlation to barometric pressure and humidity and temperature. So just passing that along.
Sure. Yeah. I mean, I was definitely looking for it. So I think I would say that I'm not going to say that there is not a relationship. I'm saying certainly from our data set, like this slide,
Right.
I don't know how to say that there definitely is one. It could be that I am not, or that I and my colleagues are not savvy enough at the plotting. Could be that there's other ways to filter the data or make it look more obvious. So we certainly expect that, and I would say anecdotally and scientifically, I think we would all expect there to be a pretty clear relationship. So I don't know if I would have to look at it more on like a refinery basis, right? Because if we looked at, refinery A here, that
Right.
sure looks like, it got hot in July, and that contact there even said he thought there was one, and we would expect one.
Yeah.
Right? Yeah.
Yeah. So
But,
it is difficult. And we were measuring by a GC in those days,
mm-hmm.
and to this day we had full on GCs. But
Yeah.
it was just that it was definitely a factor. And we had the humidity in particular was very
Mm-hmm.
instrumental, and it makes sense chemically of why that was there. And so but it is definitely interesting, and I expect this to actually expand to the chemical industry once they get around to thinking about it. I'm an environmental consultant as of today, no longer in the industry, but there's a whole lot of people that use benzene. So I think
No, absolutely.
I think it's good.
Yeah, I really appreciate your comments. And, to that point, I certainly, part of why we charted, concentration versus temperatures, we definitely expected to see that. So I don't know if, for example, this chart is there's something that we could have done differently to plot it, or maybe throwing them all together in one big set isn't the way to go to see those relationships. Maybe there's too much variation, that's site specific, that look at the whole set. Maybe if I pulled out each refinery and plotted them, it would pop out. So I was just curious, and I really thought that there would be like a stronger correlation, and like, you would see a bigger line. So I don't really know how to explain that. So I'm with you, and I was expecting that relationship. And if someone has any other ideas on how to see it or what to do with the data, I'm all for it. But thank you for your thoughts, Kathy.
And I sent you my phone number. We can talk offline and
Sure.
And continue. Thank you.
Great. Thanks.
It looks like Kathy, I'll send that information on to Nicole, since it looks like you put that in a question form to me, so I will go ahead and do that. We have one more question coming in from Joseph, He does ask that these samples are all from the perimeter/fence line. Did you get any samples from the center/inside of the site property to see what the process or the max concentration was, or from areas outside the fence or property line to see what the ambient concentration in these areas?
That's a great question. We, as a laboratory, so the short answer to that is, I don't know. The longer answer is, as a laboratory, we only get certain information from our clients, and we can't always tell, based on the sample ID. If they don't share with us what they're doing, we don't know. So within the context of this very particular program, there's a very specific naming designation or a nomenclature for all of these samples. So as part of this program, everyone does these particular points around their fence line, around the perimeter, every 2 weeks. If they want to pull additional samples from other locations, like outside the fence line or from the center of the process, they could do that, but I wouldn't know what those samples are. They could have submitted those on a different chain of custody or under a different designation. And so if the customer doesn't say to us specifically what they're doing, we wouldn't know if that's something that they're evaluating.
Okay, it looks like we don't have any additional questions coming in. Nicole, we don't have your audio at this time.
And
we didn't have your audio during that time, Nicole.
Oh, really? I'm sorry. I don't know what's happening. I'm sorry.
It's okay. You cut off. I think you'd finished the question. I think you were trying to say something else, but then it cut off about 5 seconds ago.
I'm so sorry. I'm just saying I don't know if they submitted other samples, because we can only see what based on the sample ID. And if they were doing monitoring for this specific program, it's unlikely that they would have submitted samples to us for locations outside of the fence line and inside the refinery. Prior to the establishment of this program in 2018, some of our customers did pilot studies, and then they would have done that data, other points, but that wouldn't have been included in this data set.
Thank you. And that was from Joseph. Thank you for your question, Joseph. We don't have any additional questions, or I don't see any raise the hands. I want to thank everyone for attending this webinar Wednesday. Just to let all of our attendees know, we do record this entire presentation, including the slides as well as the audio, and we do post that on our YouTube channel as well as our ALS website. On our YouTube, it's ALS Limited to find our channel, and it's the North America playlist. We not only post our Webinar Wednesday presentations, but other video resources for you to access. Feel free to also join our LinkedIn page, and you can, and our other various forms of social media, we post not only future Webinar Wednesdays, but again, other resources for you. Thank you again for attending, and thank you, Nicole, for presenting today, and I hope everyone enjoys the rest of their week. Thanks again.